very essential thing or essential commodities that I will say like this way. So let me share my screen. Is my screen visible to you all? Answers, please. Is my screen visible to you?
Yes, it's visible.
So many of you are knowing me. I am Dr. Amiya Tripathy, and I belongs to both places like Don Bosco Institute of Technology as well as Edith Cowan University. And in this today's special session, I will try to cover up some of the facts, some of the challenges, and some of the thought process that has been carried out during almost 1 decade is concerned whenever we talk about big data and analytics, as well as for the security is concerned over there. Now, when we talk about such kind of thing, let's go to some of the basic terms that we look into that. Now, when we look into the basic terms over there, then something that comes in the mind that we talk about the industries or industry perspective. So industry influence, academician and other prominent stakeholders certainly agree that big data has become a big game changer in the most, and if not all, type of modern industries over the last few years. As big data now continues to permeate our day-to-day life, there has been a significant shift of focus from the hype surrounding it for finding real value in its use. So while understanding the value of big data continues to remain a challenge, other practical challenges, including the funding and the return on investment, skills, continue to remain at the forefront for several different industries are adopting the big data. With that said, according to the research and market reports, the global big data market was, in fact, has been worth $32 billion. Maybe it's more, and maybe it's about $156 billion by 2025. So this is the market research. That's what has been coming reports over there. So most organizations have several goals for adopting big data projects, while the primary goal for most organizations is to enhance customer experiences, and other goals include cost reduction, better targeted marketing, and making existing processes more efficient in recent times. When we talk about data breaches have also made an enhanced security an important goal that big data projects seek to incorporate into that. So there were many more importantly, however, whenever we talk about, we have to stand when it comes to big data, and you will really likely to find that you are either trying to decide whether there is a true value in big data or not, or evaluating the size of the market opportunity, or developing a new services and products that will utilize a big data, or already using big data solutions as representing existing services and products like utilize big data or already utilizing big data solutions. So with this mind, when we talk about having a bird's eye view of big data application in different industries will help to you people better appreciate what your role or what is like to be in the near future in your industry across various industries. So that is what the theme that I have been trying to showcase in this coming 1 hour. So let me move to some of the basic concepts of the big data, which many of you are knowing, but still there are certain things that may come in different way, maybe a little bit humorous way also. So some of the trying to different definitions, what I just try to say, that one is of the big data definition. This is a layman's definition, whatever maybe, but that's not the case. Big data is the amount of data just beyond technology's capability to store, manage, and process efficiently. This is what the layman's language or layman's point of understanding. However, just giving a simple example, I'm talking about looking for a traditional mail. Any traditional mail has a certain amount of attachment that it is going on. Now, for example, we talk about a Gmail which has a 25 MB of attachment that you can post it over. Beyond that, you need a different kind of mechanism. That means you need a other kind of mechanism, like for example, we talk about sharing your big file with a third party, maybe in the same Google also may provide you. So that means you need a third party, you need a cloud, you need some kind of different kind of base systems over there, right? So for you 25 MB of data and beyond that is a big data which normally you cannot send a attachment. So like this way, the definition changes with respect to context, how the big data is going on there. So let me go a little beyond that, that we talk about little a quick recap on that. So organizations have access to a wealth of information that you have been known. They can't get value out of it because most of it is sitting in its most raw form or in a semi-structured or a unstructured form as of now. They don't even know whether it is worth keeping or even able to keep it for that matter, right? So that what different attributes may comes in the picture, right? We talk about veracity, value, velocity, such kind of things over there. So the value relies big data processing being a fast and agile in this today's context is concerned. Now something funny picture over there that is trying to say over here. What I try to say, I get depressed thinking of all the data out here, there, much of it hearing to be a process. And that is what the thinking process, just a funny picture I'm just trying to say over here. But this is the fact actually that we talk about that way. So we, for a normal sense, these are the place talks people are talking about: volume, velocity, variety, veracity and value. That is what the people talk about, the way the analytics has to go on. But when we talk about analytics, because when we talk about big data is not about, we talk about analytics out there. So we have to understand what is analytics trying to say. So it could be descriptive way, it could be diagnostic way, it could be predictive way, it could be prospective way, it could be decisive way. This is the way the different types of analytics that the industry or even if the market is talking about that one, right? So these are the ways any kind of analytics goes, but depend upon the context, depend upon application, this is happens over there, right? So now when I go a little bit slowly on this, descriptive analysis means this is again starting from a process basically, right? So identify the attribute, then assess the the value, evaluate the attributes and such kind of things we talk about. So at some threshold, you have to look for a crossover into a diagnostic and if some kind of predictive analysis can be carried out, right? So this is a kind of a descriptive analytics over there. Similarly, when you talk about the diagonal analytics example, you talk about you begin with a descriptive, then extract some sort of a pattern from that one, and then you can correlate the data and then estimate the maybe linear and non-linear, and that may be this example when you talk about classifying a past insurance claims, estimating the number of future claims to flag or investigate with a high probability of being a fraud. That was the every instant of time people are thinking about that one, whether it could be a fraud or it could be a genuine case over there. How do we do this? Is they require a diagnostic. Diagnostic does not mean that one only for a medical diagnostics. No, diagnostics means for going into deep into the data and diagnosing where is the vulnerability, where is the root cause, and why this is happening, and is there any something that is misleading something over there. So obviously, when you look for a predictive, when we talk about, then we talk about something determine the likelihood of possible outcomes given initially boundary conditions that you have, right? So when we talk about, again, these start with a descriptive and diagnostics and move to a predictive analysis over there, right? So we have to choose the right techniques to yield insight into a possible outcome, which is a futuristic could be there also. So that could be a prescriptive one. What this try to say that one, this again begins with a predictive. All these are a pipeline process when I talk about, right? It determine what should occur and how to make it so. That means determine the mitigating factor that to lead to a desirable or undesirable outcome that we talk about. So you would look into what if analysis basically in these cases. That means, example, finding the best setup price and advertising frequency to maximize the revenue. How do you get a revenue generation more and more, right? That is what we talk about, a prescriptive analytics over there. And there is a decisive, because all these are in industries, day-to-day activities nowadays in the back end side, not in the front end side over there. So this comes in picture. How do I get there from where? What are we talking about? How do I get here from there? These are some of the questions comes in the picture many times. So you have to look into a decisive matter in that cases. That means, given a decision alternative, choose the one course of action to do from a possible many course of actions over there, right? So that is what the decisive analytics is done. So these are the different kind of analytics that happens in the industry all the time there. Now, when we look for what I just told is not only a theory, but it's a practice in every industry. In the backend side, a backend team and back office teams are looking all the time. And back office teams are mostly on the data analytics, or database persons could be there over, right? So when you look for advanced analytics or applications, then there are some critical problems may comes in picture, right? So that's what we talk about, the role of analytics, right? So we have to took that one. That means tools and technology that gear the analyst mind to apply higher level of critical thinking can substantially improve analysis, structure information, challenging assumptions, and exploring alternative interpretation. This is what the psychology of intelligent analysis is concerned. This is what the role of any kind of analytics is concerned over there, right? So you might have a different kind of problems, could be a converse problem, could be a problem with your data mining, which you have already studied, such kind of things were there, right? So if you magnify on details, you are losing the overview. And if you focus on the overview, then you don't see the details. So such kind of problems could be there. And then you have to look for you have to look very cautiously, such kind of issues go there. Or you could be applying a statistic to understand the trends cause to loss of a grounding detail. So that could be there also. That's what happens many times over there. But the analytics continuum is all the time there. We have to look into that one side push and the other side pull is there, right? That means finding a needle in a haystack. So you have to look for a top-down analysis, which could be a deductive one, or that could be a spinning straw into a goal. That could be a bottom-up analysis, which is the inductive could be there. So one has to look into that one, what is required, is push-based or a full-based. That is, we have to look into that one. So when you look for different kind of analytical, there are different classes over there. So you have a indication, warning, or dynamical system, could be hidden Markov models, event-based analysis, or econometric models. There are different models could be there, and there are widely known, that's called the principal component analysis, which has been since so many decades this has been taken. And nowadays also people talk about a game theory models nowadays, because this is also very prominent over there. So the application of a a 2-person or an n-person game theory to competitive and collaborative situation involving a strategic interdependencies. So these are the new terms that is people are applying in analytics. That's called a game theory model. And apart from this, called a logic system, which is again quite old enough, but again these are also very much required. These are the different kind of analytical classes has been used. Apart, there are other things like, for example, utility models could be there, control theoretic models could be there, survivor models could be there, evolutionary computational could be. So these are some of the models, some of the analytical classes that has been using behind the scene when comes to analytics is concerned over there. Now, so when analytics is about some sort of a discovery, so you have to look for a novelty discovery, you look for a class discovery, you look for a different kind of association among themselves. That is we talk about it. So finding some unusual pattern could be there, right? Now, so some correlation. So all these are kind of a discovery is also looks into a kind of analytics. People are talking about that. So the goal of analytics is what? To monitor or anything, or to sense making. That means that is called, that we nowadays talk about a data analytical science. That means that's what we talk about. The goal of analytics is like this. So data collection, you have a measurement, you have observation, that is from a different kind of a sensor or whatever it may be, and to monitor or to alter or to make a so-called sense making. That is called the data analytics is concerned, right? So now what exactly sense making? So in the end, what do we require? What does that even really mean to me or him or her or my friends, etc.? So what is the plausible explanation for this one? So sense making is mean that one fits data into a frame of or a mental model. Can be a physical, can be a social, can be any form of that one. So requires a different or higher level of intellectual engagement, not a massive translation could be there also. So it requires a basically a sense making something over there. Now, when we look for such kind of thing, there are so many challenges of how to deal with the ambiguity, how to deal with the too much data, and have we let algorithm and large centralized data centers not only control the remembering but also the meaning of the interpretation of data. So these are some of the things that has been comparing. We talk about there are so many IBM tools available to look into that, how to make a sense making things per there, right? So it could be instrumented, it could be interconnected, it could be intelligent also could be there. So we know how to do a massive data collections and have the ability to index them also and calculate, search and share them. But what seems to be missing is the ability to review, to reflect, to recall and ponder. This is what the challenging things were there also. So when we look for a sense making, one has to look for the grounded identity of the construction. We have to look for a stress spectre. We look for a social context. We look for a ongoing or dynamic point of view, right? You have to look for a plausibility and then rather than an accuracy. That means understand only needs to be sufficient, not a comprehensive one that you look into that one, right? So when I say that one, an application, when I talk about a mobile crowd sensing, so individuals with a sense and computing device collectively share information to measure and map phenomena of common interest within the community of people. Now here we talk about a participatory sensing. That means individuals are actively involved in contributing sensor data, or there could be opportunistic sensing. That means autonomous and user involvement is minimal in this case. So you have to look for a localized analytics at a device level or a near field level. That we talk about the NFC, near field communication, right? And we look into also the aggregate analytics at the as a central repository sometimes could be there also. But in all the cases, there could be a privacy issue, there could be a security issue, there could be influence, the information privilege or a breaking the privilege issue could be there also, right? So potentially, collecting sensitive sensor data pertaining to a individual is definitely a privacy issues are there, and there is a challenge to this kind of things were there also. So then we talk about some sort of the knowledge centric system, which you may have the user centric could be there could be adaptive could be there could be smart operation. All these are the types of systems using a advanced analytics. Is we talk about that system that reason, system that learn, system that these are some things that we talk about nowadays. Everything is automated. Everything we talk about the robotic automation. We talk about automated system. Then all this comes in picture behind this scene over there. So when we talk about the analytic paradigm, so you have to, there are 10 points one has to look at. When you will be expected to do something with the information, and there really is more to know, and you will have to know more about knowing. So brain science and decision science are converging, obviously, in this case. So the environment is changing our brain, obviously. Information management is the essence of the leadership that we talk about that one. So these are the different paradigms. It has been changing happen over there. But math matters. Math is matters over there. Behind everything, there is a lot of mathematics in there. So you have to understand the knowing can change the world. That's what the new paradigm is happening over there. Now, when you look for analytical change, that I just a few minutes back, I was trying to say that one, a needle in a haystack over there. So with all the data available, find the key pattern that indicate a sequential chain, a single event, perhaps a sequential event, not this signal in the noise problem that we talk about. So have we seen this pattern before to determine its characteristics, or not just they exist over there? So you predict what occurs next, because these events occurs in a pattern, obviously, right? So here, when we talk about the how to identify the relevant fragment of data easily from a multitude of data source is a question, is a thought-provoking process, obviously. And of course, it is difficult to determine what is the right answer is in advance over there. Now here, if you look for the picture, the needle hasn't grown as fast as the haystacks over there. The problem that one, we need to new analytics methods to deal with the large, more complex data and the problems. That's what the issue over here. So the finding a needle in a haystack is a problem. What if the needle happens to be a complex data structure, right? It happened that when the brute force search and computations are unlikely to succeed due to inefficiency. It happened that one. It happened that one absence of evidence, which is not evidence of an absence of this could be there, right? So what processing do we need to do before searching such kind of thing? What we have to look for the quality versus the quantity also. What data are required to satisfy the given value proposition over there? What precision, accuracy, and reliability? These are some of the thought-provoking process is coming in picture in the industry sector is concerned. So the challenge that consider finding a few packets in the millions or a tens of billions flowing through a network that carry a virus or malware, right? So how do we track the provenance of the derived data or information? Right? So example, what if the needle must be derived rather than the found over there? So these are the critical questions in the form of a data that comes in the picture over there. So let's look into a small video, which is present the context is equally important. Many of you must seen this video, but still it is important over there. And there are a lot of analytics involved in these cases for this one. Let's look into that one. This is why. This video is a little bit futuristic one, but it is equally applicable to this one.
This is a nice layout, Jenny. But I think we need to improve on the headings. How about this?
That looks good. Let's try to put them together. How about making this part blue?
Looks perfect. Now let's begin our editorial meeting to discuss the special issue, ICT, Changing Society and the Way We Live. Could you start the preparations for the meeting now?
Sure, let me handle it.
We talk about virtual reality, we talk about augmented reality, and this is what we are talking about here. What you see in this video is nothing but a virtual reality. And of course, it's augmented reality
the meeting
also.
is about to start in a few minutes.
It was such a beautiful morning, I lost track of the time.
It's been a while since we had a sunny day like this.
Thank you.
You have a video message from Dr. Johansson of Nokka Clinic.
Could you play it for me?
Sure.
Mr. Riker, I need your permission to disclose the data that you sent the other day so you can be checked at a general hospital.
No problem. That's done now. I have to be in the meeting.
Okay.
You look great, Raikkonen. It seems you've perfectly recovered from your illness. Well, I monitor my health through bio and wearable sensors that send my health data to my doctor. Everything is under control. I'll tell you more about it later.
In the aftermath of the powerful cyclone that hit Mumbai, India,
Sara, 大丈夫かしら。あ、もうこんな時間。お待たせしました。
Sorry to have kept you waiting.
すいません。
Don't worry, I just came in myself.
サラ、
So Sarah is not here yet, is she?
I'm afraid so.
Sarah!
Sorry for being late.
Are you okay, Sarah?
Yes, boss. Actually, I want to go visit and gather data on how this ICT network could contribute to the educational environment, especially during times of disaster. So please allow me to go and give my report first.
All right.
I was right in the middle of gathering data for my topic, education and ICT network, when the cyclone struck. The city suffered severe damage from the cyclone. But although there's no electricity and gas, the communication networks have almost remained undisrupted.
Wow.
Since agencies have a clear grasp of the extent of the damage, rescue operations appear to be going smoothly. And since the shift to the clouds are at a very advanced stage, companies and schools have already started their operations in new locations. And that is why I will be going there to cover the districts where they will be making use of the.
So that was, I was trying to say, the kind of the data exchange happens in behind the scene, and the kind of the different volume of data and variety of data that has been, you see this one, how this has been happening. That one, though that was video was a specific video, but that was the way the things are moving with the data center, cloud, and all things are happening over there. Now, when you look for the comparison of our data characteristics by industry, this such kind of things may comes in picture. So you have if you see the picture over here, I talk about the very hot, or to the hot, to the moderate, to the low, or to very low. These are the different kind of industries that we talk about. Maybe banking, maybe communication sector, maybe education, maybe government, or maybe healthcare, or such kind of thing. These are different way. Just a look at how the things were, how the volume of data, or the velocity of data, or the variety of data has been used with a scenario over there. So let's move on to some of the things over there. The banking industry, when I talk about that one, the challenges is that one, early warning for securities and fraud and trade visibility, and the card fraud detection and audit trials. And these are some of the challenges over there. So the Security Exchange Commission is using a big data to monitor financial market activity by using a network analytics and natural language. And this helps to catch the illegal trading activity in the financial market. And where we talk about, obviously, we talk about early warning of securities or fraud is very important in these cases over there, right? So such kind of thing, when you talk about a banking sector or any other sector, and there are a lot of issues over there, right? So when we talk about this, we talk about the application of big data in the banking and security industries that we talk about, right? The Security Exchange is using big data to monitor financial market activity, and they are currently using network analytics and natural language processing to catch the illegal trading activity in the financial market, right? So the retail traders, big banks, or the different kind of funding agencies and other so-called the big boys in the financial market use big data for trade analytics use in a high frequency trading, pre-trade decision supports analytics and sentiment measurement and predictive analytics, etc. So this industry also heavily relies on the big data for a risk analytics, including the anti-money laundering, demand enterprise risk management, and know your customer and fraud mitigation. So big data providers are specific to the industry, include the 1010 data or the Panopticon software or a stream-based system or a nice Actimeasure and the quarter affairs. These are some of the systems that software has been used in these cases over there. So there are so many examples. I talk about a communication or a media or entertainment, right? When you talk about the challenges, this is collecting, analyzing, and utilizing the consumer rights and all things to that, right? When you talk about such kind of things, well, so understanding the pattern of real-time media content is a challenging task over there. So here, when you talk about organizing in this industry, simultaneously analyzing customer data along with the behavioral data to create a detailed customer profile that can be used to create a content for a different target audience, or recommend a content on demand, or measure content performance, right? So here we talk about the Amazon Prime, which is driven by to provide a great customer experience by offering a video, music, and Kindle books in a one-stop shop, also heavily utilizing a big data, right? So big data providers in the industry include the Infosys, Splunk, Pervasive Software, and Visible Measures are there. There are some of the industry's names I'm talking about. So like this way, there are many things. Example, you talk about the healthcare providers, which is challenging is the rising medical cost and unavailability or the inadequate usable data could be there also that way. So if you talk about education, of course, nowadays is a big challenge in education over there, incorporating data from the varied sources and courses, and untrained staff and institution about a big data is a measure of concern over there, and issues of privacy and data protection is a big things over there, right? When talks about a manufacturing, okay, a lot of things were comes over in these cases. So increasing the volume of the complexity of and velocity of the data due to rising demand of the natural resources over there, right? So you require enhancement of a supply chain capability from a big data being used to increase the productivity in this cases, right? So unutilization of data, which prevents the improved quality and energy efficiency, is a major concern over there. So those are some of the. If you talk about government, there are n number of things over there. It could be introducing and challenging or interpreting of big data could be there over there, right? If it's insurance sector, we talk about a lack of a personalized services pricing, targeted services to a new market segment is need of our. So here, of course, we look for customer insight for the transparent and a simpler product is missing, and which is a need of our. Where we talk about the claim management or a predictive analytics, from a big data has been used to faster service that we talk about. So in a retail, it's a big way it is going on with respect to pandemic one, and it really is a big way analytics has been going on, right? This is we talk about a optimized tapping through data from a shopping patterns and localized events is a new change has been observed with the pandemic is concerned, right, over there. Now, in case of a transportation, right, the transportation has taken a new change with respect to the pandemic is concerned over, right? So data from a location-based social network and a high-speed data from a telecom have affected the travel behavior with respect to pandemic is concerned, right? So hence a new way of the things has been going on, and some of the application of a big data by the government or a private organization and individuals include the traffic control and route planning and intelligent transport system has been talking about that nowadays over there. Now, when you look for energy and utilities, the 60% of electric grid assets will need a replacement in this decade. Obviously, it is true that one, right? So global installed wind capacity increased by a 12.4% of both. So you need a different kind of thing. You need a smart meter reader allow data to be collected almost every 15 minutes, and this granular data is being used to analyze the consumption of a utility of a better, which allows the improved customer feedback and better control of the utilities. That is what the energy is concerned about. That. So I'm just giving a briefly on that. Moving back to a little bit our own core concept, that is, we talk about a relational or a non-relational data, right? We talk about, when you talk about, these are the rational, predictable, and traditional. That's a relational. Whereas the non-relational, these are something like agile, could be flexible, could be modern. Right. So here the big data challenge is more towards something called a called archives, different document, different applications, different media, data storage point of view, machine log data or a sensor data. All these are big challenges are comes in picture over there, including all the way of complexity, velocity, value, or volume is concerned over there. So when we took for a big data analytics, this focus on from a traditional BI to a big data analytics, we talk about a predictive analytics or towards moving toward a data science is concerned. So instead of a causation, we talk about a correlation, we talk about nowadays over there. So when we look for different kind of cases, we have to look for the real-time intelligence, business reporting, and data recovery, right? Wherein we talk about a latency, reliability, we talk about a data quality or self-services, we talk about a performance point of view concern, right? So all these, when you talk about a architectural driver to a reference architecture is what moving over there now. So we talk about a architecture could be a rational reference architecture to be towards, we talk about now, you talk about some points I'm talking about here, a reference architecture where we talk about 3 points over the key components, the data warehouse and data marts and OLAP queues we talk about here now. Now moving to add here, these are the key components. The other components for a non-relational movement are the NoSQL databases, distributed file systems, MapReduce, and search engine. It could be these are the a movement of or talk about this one. Now, when I look for the point of the extended relational on a non-relational, these are the points. You can have a large volume of data which is extended yes or no. That's the thumbs up I'm giving over there. So we have a self-services, ancestor processing, high data dimensionality, extensive security over there, reliability, and low cost. All things which comes in key picture over there for architectural point of view over here. Moving ahead, when I talk about moving ahead, I'm talking about I saw that one relational and non-relational. Now the big data analytics use case, we talk about data discovery one aspect point of view, right? So when we have to look for the data storage point of view, where we talk about, you talk about SDFS, which is distributed file system, from a to analytics, which is a query reporting, or could be a map reduce, can be used whether towards a presentation for a web browser, or it could be your analytical app is concerned over there. From business reporting point of view, again, you may use a ETL or integration point of view, and looking for a, as example, I'm talking about a data storage, but I'm talking about a Vertica is a software where you can use also SDFS can be used also, where you can use as a Tableau or something like that, and you can look for a SQL query reporting and or could be map reduce. It can give you a different way of a web browser or a native desktop, or could be a mobile devices based any kind of application that can be carried out, right? So when you look for a, the real-time intelligence is concerned, then you have to look another kind of things over there, where you have to look for a low latency reliability on things. Let's look into a small case that I'm talking about, where we talk about a visual environment for building a custom and mobile application. Just I'm looking a small video over here. Let's for a few minutes to look into that one. So this
to understand how big data and analytics works, you have to put it in the context of how things worked before big data. Let's do so by looking through the lens of a telecommunications company. Historically, telecom companies had what they thought was a lot of data, captured from transactions and key applications. It lived inside their firewall and was stored in silos. One set of data for landline business, one for mobile subscribers, one for small businesses. To do its financial reporting, the IT team would extract data from these silos, integrate it, cleanse it to ensure its quality, structure it in a set of columns and rows, then put it in a data warehouse where analysts could report, analyze, model, and plan based on it. By doing so, key departments like finance, marketing, and network operations could create a historical view of what happened and develop insights on why it happened. Analytics on structured data at rest is essential for things like quarterly and annual financial reporting, sales trends by region, as well as monthly network outages. Then, a few advanced telecom operators began applying more sophisticated forms of analytics to this information, helping them see patterns of what could happen, giving them new insights into issues like potential customer churn and marketing effectiveness. About 5 years ago, something fundamental changed. The world started getting smarter. Everything, cars, running shoes, medical devices, even people through our devices and social behaviors started being instrumented. They started creating valuable data. Every time we pick up our smartphones to make a call or send a text, it creates a call detail record. CDRs are structured records that include things like the number you call, the routing, and the length of the call. Hundreds of billions of CDRs are created every day. Enormous advances in infrastructure like advanced processing power and in-memory capabilities make it possible for telecom operators to analyze the deluge of CDRs. But for many, the volume is overwhelming. While call detail records are structured, most new forms of data are not. So the variety of this new data creates challenges as well. Fortunately, the infrastructure and the software continue to evolve. Advances in data management software like Hadoop make it possible to explore any kind of data while leaving it in its original state. For a telecom operator, this means they don't have to structure the data before getting insights from it. Instead, they can put different data in a giant exploration repository and start to do analytics on all sorts of data at rest, both structured and unstructured. This allows them to discover interesting patterns, developing new insights around key things that matter, like their customers. And because the patterns are based on all data, meaning structured data like billing and CDR data, unstructured data like customer tweets, and notes from customer service agents, they're developing a holistic picture that helps to define the best course of action. For a telecom operator worried about customer churn, this means being able to proactively reach out to a customer with a compelling offer before they decide to leave.
So that was the one that I talked about, where the big data analytics has been used to look into that on how to retain the customer, and companies are looking into that and how the things analyze. Though there was much more things were there, but we have just look into that one. So when you look for architectural decisions, then you have to look for the extended relational architecture. You have to look into that one, right? So you have to look for different architectural drivers. You have to look for that one. You have to look for the different kind of a trade-off. Could be extensibility, could be data quality, could be a self-services, and both extended and non-relational and relational point of view, one has to look into that one, right? So you have some sort of a solution architecture could be created looking into different kind of a technologies that has been used to the different kind of a servers that can be used, and different kind of a hardware or software can be used that has to be required into that one, right? So I'm talking about you're talking about here Amazon, I'm talking about here Amazon SQS, or I'm talking about AWS Redshift. These are some of the things I'm just trying to say over here. So here architectural decisions are very much required when it comes to designing for a kind of a backend based systems we're concerned over, right? So whether you talk about, for example, I'm talking about an elastic load balancer. That means when the loads are coming out, so we have to look into that. How can you dynamically balance a load elastically? That means when I pull and push, I can do that one. Such kind of things one has to look into that one. So you have to look for a different kind of a Hadoop cluster, right? Or maybe a HBase cluster, or maybe different kind of API or reporting tools that can be used to look into the better suitable for the time is concerned over there. So when you look for for designing any kind of a big data solutions, you have to understand the data user and sources, and you have to discover architecture drivers. You have to discover you have to look for the select proper reference architecture, do trade-off analytics or analysis, and address and both pros and cons over there. You have to look for a map reference for the architecture of the technology stack is concerned. You have to look for a prototype as well as a reevaluate architecture. All these I'm trying to say that how to design a big data solutions. We're trying to say that one, right? So when you look for a big data technology, many of you must have aware of that one. Still, some of the things I'm just going to quickly. There are two kind of things. There could be operational big data or could be analytical big data could be there. When I look for operational point of view, one is look for the different ways. Example, I'm giving a ticket booking system, or looking for a social media, looking for organization, or looking for the online shopping. These are the basically operational big data. When look for analytical, right? Of course, look for them mostly on the backend side. So that's example, I'm talking about a weather forecast, or it could be a stock market, or could be a or could be a space mission, or could be a medical point. Those are all the analytical big data where we look for, and something like instead of operational, we talk about something like analytical point of view, right? So there are some of the things that you have to. I'm just quickly glance of this one. Could be Apache Hadoop, which is a distributed data processing environment, and which use a commodity hardware and software, and look into that one, right? So there are some other things could be of something like a Hadoop, or could be IBM, could be ITL, or could be Intel, could be Cloudera, or Cotton Network could be there also. There are other things, something like MongoDB, which can be a NoSQL document database over there, developed by the MongoDB in the year of 2009. And this is mostly, a stable person could be something like this way, right? And which maybe use SQL Server, MySQL, something could be there. Other thing, there are technology could be Rainstar could be there. Splunk and Hung could be there. There could be Presto. There could be the Netflix or something you are using. There could be Rapid Mining, which from data mining point of view, right? Which is a powerful tool for the graphical user interface for the data mining is concerned. Which could Rapid Miner is there. So like this way, there are so many tools and technologies available for using the big data analytics is concerned, right? So then one of the famous one is the Apache Kafka, which is again a distributed streaming platform, which nowadays has been used. Kafka is a concern, right? And then another more widely used is this Splunk, of course. This is used mostly in the application of management, particularly web analytics and the security compliance. This is also used over there. So these are some of the tools that I have been just highlighting here. And another the tool that is called the Tableau, which is used for mostly for the for the visualization point of view, and that is what has been widely used over there, right? All these are both mostly on the emerging big data technology tool, including the TensorFlow, including the Docker, Kubernetes. All these are the cases over here. Now moving to, for example, a small video for developing a product, how people are looking into that one. Let me look at a small video over there. This is from an IBM Watson video, and many of you may be seen, but still it could be interesting one. That one. Let me see this one, right?
This team uses advanced analytics to draw insight and action from external data sources such as social and weather, and from internal enterprise data. We work for the world's largest B2B and consumer brands, using both structured and unstructured data sets to drive real financial results. This is a story about one of the ways IBM is using social analytics to help fashion retail clients increase revenue. The hero of our story is, well, a skirt. A green skirt worn by a top actress in Asia on one of its top most popular television shows. How popular? 100 million viewers in Asia alone. The reaction to the skirt is immediate. Over 1 million women from Asia post their positive opinions in social media within the first 10 minutes of seeing it. Meanwhile, over in Europe, at the headquarters of Fast Fashion Incorporated, or FFI for short, this sensation doesn't go undetected. Using IBM social analytics, FFI notices this huge spike in interest in the skirt and sends a trend alert to the brand manager. The brand manager fires up her social command center interface and, within minutes, is able to access the data to completely follow the trending sentiment, even reading some of the original comments. And then she makes the critical next move. She takes action. She emails an opportunity alert to the product team, suggesting they develop a new limited edition of the skirt, using social data to vary fabric, length, and color to appeal to local tastes. The product team leader initiates his own social command center and, using social analytics, confirms that, yes, the skirt is definitely a trend. He contacts the design and distribution team to develop a strategy. They introduce a set of exclusive offerings available for immediate pre-order on FFI's online boutique. It's priced at a premium markup of 25%. And because of the positive coverage from the fashion blogosphere and traditional media, it's guaranteed to sell out. So what connected FFI with the fashionista TV watcher and a $100,000 profit retail opportunity? IBM's social analytics system and a single piece of actionable insight. And what was the IBM social analytics solution? It's simple. Mix and match services, cloud-based technology, and plug-and-play processes. And it all happened over the course of a single day, no matter what.
So this is what the product development talking about. Now talking about another project which is done in DVIT, and of course it's quite a little bit old enough, but again we have used so many big data tools and technology to look in. That's called the Agri Cloud, at the boon from Indian farming is concerned, right? We talk about the weather problems, we talk about crop related problem, we talk about seed problem, we talk about the profit problem, we talk about the scarcity of capitals we talk about. So we have talked about the agricultural marketing and impact of the climate change. We talk about this kind, right? So wherein we talk about this is a simple diagram, a diagrammatical view of how we have looked the weather, different kind of e-data, that's called the data bank we have been talking about. So data, traffic, growth monitoring, expert constellation of the database, farmer database, soil database, all the things we talk about, e-farming, e-commodity exchange, and the telemedicine to the crops, and we talk about real-time computation over there. All these we talk about towards the big data use is concerned, right? Where we talk about a different kind of e-data bank, we have been linked to different across so many Indian sites are concerned over there, right? So we just showing some of the glimpse over there where we talk about the lawn farming and get the help from the cloud that we talk about, right? We talk about e-farming, the art of farming also we talk about, we are showcasing over there. We talk about different kind of medicine for the crops over concern over there, right? We talk about a commodity exchange also in this cases we talk about, right? Different kind of services we talk about that one, right? Where we talk about the Agri Cloud, and which is a product-based solution that we have been talking with a use of a big data analytics is concerned. So that's what some of the tools have been used, the MongoDB Studio and a Jamf and a Bootstrap, RoboMango, and Amazon Web Service has been used during those days over there. So some of the glimpse are just trying to so that you can be motivated to use the big data technology to work in your project is concerned, right? Some of the things I have been using over there. Even you're talking about a JSON for a database we have been used over there, right? So that's what is a small glimpse. I'm just trying to show different things over there. Now moving ahead, I'm talking about something like this. I'm just talking about the big data and security. Where are we now, as of now? So when you look for as the things are moving, there are advanced threats where there also. So massive increase in advanced malware bypassing the traditional security defenses obviously is there. So volume varies substantially and among different industries, obviously that email-based attacks are growing with a link and or even if SMS-based, even if text-based, in WhatsApp message-based also the attacks were there also, right? So cyber criminals are increasing employed limited use of these domains in their sphere of phishing emails could be there also, right? These are some of the threats obviously there. Now, what exactly that if you look to the figure over here, these are some of the advanced reports. So organizations on average are experiencing the malware-related activities once in every 3 minutes over there. This includes the receipt of a malicious email using clicking a link and an infected website or infected machine, making a call back to a command control server. This is what they think. So mostly affected is the technology. Obviously, when I talk about starting from a legal to the logistic, the technology is the most effective one for the threats is concerned over there. Now, when I talk about such kind of thing, we are just trying to say that how the malicious criminals breach occurred over there. The mostly you talk about a targeted attack and advanced malware such, and I'm just highlighting some of the things over there. So here that are some of the things that I'm just highlighting over here. Similarly, when the breach are discovered, that one immediately or within 1 week or within 1 month, or this could be, there are different, to be malicious and non-malicious. I'm just giving a glimpse over there how to look into that one, right? So this is another the reasons for failing to prevent of the breach is again is the question comes as a lack of in-house expertise is the matter of concern over there. That's what he's trying to say that one. Sometimes it is also so-called the inadequate security process also in the place. That's one another one that comes in picture, right? So this requires a greater matter of concern over there. Now, when I look for the extrapolated cost, and you see this one, this is the kind of a dollar cost has been worldwide. Look into that one. That is what I'm talking about. This is the big one that I'm talking about, wherein we talk about the malicious and non-malicious, and this one 32% when I talk about is more than malicious. This is a big money has been taken into account over there. Now, when I look into such kind of things, you have to look into that one. The threats like the tipping input points could be that the stealth malware or targeted attack or a social engineering. Many of you must have known such kind of thing. But new technology challenges are something like a cloud-based one, or could be a byte, or could be a consumerization. That was or could be virtualization. These are the challenges that is coming picture as of now over there. So what which we talk about the traditional defense is something like this, but the traditional approach is something like this. But now one has to think a different level of when you look for the data in motion. Data in motion, when you talk about, then we'll look for a different level of security. That is what we require over there. So what do we need to do with the big data source? So system log files that can grow by a gigabyte per second. That's that one. Network or data capture, so which can grow by a tens of gigabytes per second. That that one. So you need also intrusion detection and or a protection log file that can grow by a tens of gigabyte per second. So application of log file that can grow by a gigabyte per second. So that we need a different big data tools to look into that one for as far as security is concerned over there. That's what the need of our over there. So when I talk about what is called the conventional versus advanced approach, then for information security we require a different approach that is called the both control point of view, both perspective point of view, goal of the logging over there. We have to look for incidents management, look for the treat of the intelligence point of view, look for the success by defining by different kind of advanced approach can be. This example I'm talking about a perspective. So we have to look for a data centric. If my option is for a data, then I have to look for a approach toward a data centric approach to how do I secure my data. That's what monitoring, right? So as example, when I talk about incidents management, I have to look for a big picture that's called find all the dissect attacks patterns that I have to look for. When I look for a threat from intelligence point of view, I have to look for develop a deep understanding of attackers or a current target and modus of operandi I have to look for, and of course your own organization, key assets, and the IT environment could be also target one. So I have to look for these kind of things over there. So how can the big data help? Of course, you have to look for a SIEM on the steroid, or could be fraud detection, could be APT detection, or could be integration of IT and physical security both require there, or maybe combination of all such kind of things could be there also. So when I'm looking for these kind of things, we look for a logs, we look for a network traffic, we look for an IT asset, we look for a different sensitive or valuable information. We'll look into that one, or these kind of a different kind of threat intelligence can be taken care, or different kind of user behaviors can be taken care. So this is what the big data to collect for the security point of view is required for. So when you look for the analytics, we in these cases for security point of view, you have to look for a real-time update. We look for a behavior model. So we have to look for the correlation among those things. We look for the heuristic probability, and all these we have to look for the interoperability and advising analyst or active defense system we require for to protect the big data analytics is concerned over there. So the security challenges are something like this: the bigger the data, bigger the breaches. New technology, of course, security or definitely later obviously comes over there. They are more vulnerable. So you have to look for a information classification and a different kind of a subnetting required. And of course, you have to look for a big data in cloud or bio, then require more problems over there. So your new security technology is required for all such kind of things over there, over right. So when you look for a security, the security risk over there, new technology will introduce a new vulnerability. So potential for a backdoor and a default credential can be required. So attack surface on the node in a cluster may not have been reviewed, or maybe servers adequately hardened. So you require a user authentication and access to data from a multiple location may not be sufficient to be controlled about there. So these are the big data security risks are concerned. Or there could be some sort of a regulatory requirement may not be fulfilled with respect to this one, which may be significant opportunity for malicious data input or an inadequate data validation can be there also. These are some of the security risks with respect to big data are concerned over there. So when I look for the privacy concerns are concerned, we talk about a de-identified information can be a re-identified. That is what we talk about. So data collectors claim that aggregated information has been de-identified. However, it is possible to reassociate anonymous data with a specific individuals could be there, especially since so much information is linked with smartphones over there. So that was the major of concern, right? Possible deduction of personal identification information can be there. Wherein we talk about a non-personal data could be used to make a prediction of a sensitive nature, like a sexual orientation or a financial status or something like that could be there also. There could be risk of a data breach and increase also that. And that means the higher the concentration of data, the more appealing to a target in a makeup of hackers over there, and the greater impact as a result of breach is concerned. So this is what the major concerns over there. So on summary, what I'm trying to say is with all new technologies, security in big data cases seems to be a afterthought at best, obviously. So big data breaches will be too big too obviously, with even more serious reputational damage or can be legal repercussion could be there also. All organizations need to invest in research and study to emerge a big data security analytics landscape could be. This is again a threat, still is an infant on these cases over there. So big data has the potentially to defend against the advanced threat but requires a big rethink of approach over there. And of course, relevant skills are very successful deployment, obviously, but only the largest organization can invest in this session. So offer existing for more than 97% that can enhance existing technologies using a cloud-based solution is the need of hour. That is what we require over there. That's what my the talk of the day. So thank you for attention. Any questions, please let me know so that I can answer some of them on that. Any questions, please? Any questions, please? If not, then thank you very much. And this is quite the end of the sessions, and because the time is limited, obviously.
Yes, sir. Sir, I would like to thank you for the session. It was indeed a brief description about data analytics. And we specifically being the other elective students, we had very less idea and knowledge about whatever big data analytics, the basket of big data analytics contains. So this was indeed very helpful for all of us. And thank you for your precious time, sir.
Thank you. So shall I leave now?
Yes, sir. I think.
Yeah. Okay.